Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to my DIY metal milling machine video series. Also known as the on this channel as the Green Machine Mill. So let's go ahead and look at. Oh, I remember I've been super busy getting ready getting the shredder ready for production in Texas that I keep forgetting about these guys here. So what I really want to do is that this looks good. Need to talk to them a little bit about maybe changing this ball screw over something a little different, as far as the traditional ball screw where this is kind of bigger, but I still need to machine that anyways. But the other thing is the what's it called? This clearance I'm not too worried about, because again, there's supposed to be a flat spot down there, so it's supposed to clear anyways. So it should actually probably be somewhere over here in this area. And again, there's going to be a flat block. There's going to be a 1/4-inch plate that goes underneath this guy to shim these guys up here. And it's going to keep... And then these guys are probably also going to need to protrude, because right now they're pretty much exactly flush here, which is not going to be ideal. So I'm going to change that so these guys are actually popping up and over the... What is this? Oh, that is the motor, right? So, well, yeah, we need to shim this up 1/4 inch. Yeah, so put a 1/4 inch plate under there, or an 1/8 inch plate, or whatever that holds it down, and in 4 places, 1, 2, 3, 4, 1, 2, 3, 4, and then also a block on the inside here. We're gonna need something there that will push this thing back and forth. Because this guy basically stays stationary. So let's see, how does this work? So the screw stays there, and then this guy goes... Yeah, so it stays stationary, and then this screw is basically fixed on this piece here and goes in and out. So pretty much there needs to be a plate under this guy, the plate that goes under here. And these grease fittings obviously need to be out here, but that's okay. Grease fitting here, grease fitting here, grease fitting here, grease fitting there. So the plate goes underneath here, and then it needs to come up and into this section and come around and bolt around this guy with a piece of really, really sturdy angle with probably 2 gussets on either side to make sure that it's super stiff and that it could go back and forth, because we have plenty of clearance on this side, plenty of clearance on that side, to make this very, very strong so that it doesn't flex when you push it back and forth. So that's kind of the drive, and then same deal up here, down, and again the motor here, drive, the motor here, drive. I mean, it looks really, really small on this machine, but it's a decent sized motor. I think Tormach's got quite a bit bigger motor, so maybe we could even do that. I think they have some NEMA 30 somethings. Do they have that on their website? What about Tormach 1100M? Typical system weight 1,600 pounds. High-speed spindle. It's not saying here. Hmm. Ooh. What is this? I guess to go around the machine? And also it's offset to one side. That's kind of interesting. Oh, I guess, well, the ATC's got to go over here, so. And then cable chain. So this is up 96 inches. And how far is it above the floor? It's not telling me here. And then the machine, because I would really like to know where this chip tray starts. I mean, basically the machine's here. Because again, my water jet's going to go underneath. Oh, that's another thing. Where am I going to put my chip tray? I mean, I could just use a hose, you know. It's not that big of an issue. Okay, so I mean, it'd be cool if if all the coolant flooded down here and flooded all the chips down in here, and then it's siphoned out. That is a good idea. I'll have to figure something out about that. Maybe it goes down different channels around it or something. Or maybe for right now I'm just going to have to use a hose and suck all the chips out. 2.3 meters, 1.8 meters, 69 inches. Whoa, that's a big guy. There's a 20-inch clearance here and a 20-inch clearance here to go around the machine to the back. And then here's a stepper motor right there. I'm guessing that's for the Z, I mean the Y. So from this, I mean, I could figure that out, what it is. It's a 9-meter swing. Well, that's kind of cool. What else do we have to see here? Here's a full spec sheet. 7,500. Okay, so we're definitely low, but we are using a BT40. Hard drop bar, fourth axis, smart cool cooling system, rest, chuck lathe, full enclosure, high speed spindle. Okay. 17 inches. I think we're doing better than that because our spindle, our motor is going to be offset to kind of give it, it's going to be in line with it, so it's going to be very, very narrow. And I really like that. So we don't have, it doesn't have to be that tall. Customer table, hand scraped, 100 ways. Wait a second. Okay, so this still has ways and dovetail ways. So maybe it's the MX series. Interesting. So servos in there for $2,000, and then the MX Plus. The MX is it looks like that's the one with the linear rails. And then it says you want a stronger ATC compatible BT30 spindle. Okay, so basically we're doing BT40, but that's okay. All right. Oh, and then what was that horsepower rating? Spindle 2 horsepower. Okay, so what I'm thinking that we're going to do here now is let's figure out how to do the... Ooh, I didn't quite fully do the spindle yet. I'm going to ask for a model of the spindle. And then figure that out as well. So let's see here. AliExpress.com. Oh, also, what are we looking at as far as weight so far? Properties. We are looking at 9,500 ounces. So we're about 600 pounds. So 600 pounds, and obviously it hasn't been bolted to a chip tray and a table. It's all going to increase the weight and decrease the vibration. And we don't quite have the spindle all put together yet. We need another lead screw, and we need another motor. So obviously this other motor is going to go underneath here, which we could do that right now. And then this is probably, like I was saying, this is probably a little heavy compared to what it is in actuality, because it's basically solid cast iron, or actually solid steel right now. So yeah, it's basically going to be like that. For this way saving, I mean, it could actually even be over here. That's not a problem. That's probably not that bad of an idea. Let's do that. What kind of clearance do we have? Oh, plenty. There we go. So yeah, basically it'd be just like that. And so now this could be narrow here and no issues with clearance, because this is going to go way further than it anyways. And then it could be shorter here, because obviously if we do that, then this needs to be taller. And if we can, we'll put a skirt down here. So and what we'll have is we'll have a small coolant tank underneath this probably. So the plate goes here, and then I'll have a hole. And then this guy will have tiny little, like, maybe some laser or water jet cut piece of plastic skirt or something, or even like just scissors down through here, and then so that way liquid come out and go down. And then basically it goes in the chip tray, and then it falls underneath, and then it goes down here, and basically goes underneath the machine and drops into a tank down there with a mesh something on top. Okay, so BT40 power head. Let's do this one. Okay, so let's see here. So basically we got this. Okay, so we got this done. Now we need this, and we need that. Okay, so this is basically symmetrical, so I'm not really too worried about that. But let's pick the bottom here for the spindle head. And basically it looks like it's about 100 and I could have swore I did this already. Anyways, circle, center diameter circle. 1, 2, 2. I think my cat wants out. I'm gonna pop the door open for her. I'm gonna say it's 120. Yeah, cool. And then that jumps up about 17 millimeters. Then we have another circle. It's 75. And that jumps up 30 millimeters. I wonder if this cast iron or steel. It says here 6,000 RPM. Does it have a shipping weight? No, no shipping weight. Interesting. Anyways, oh, it says belt driven. Oh, yeah. So, okay, now let's do this last part, which is this other piece here. 2026. This is 30 millimeters. So let's flip around. Flip around. What about this piece on the end? So yeah, it's not telling me what this is and how tall that is. Oh, yeah, it is. Well, it's not telling me how big it is. I think it's about... It's about how big this other side is over here. And that one is 75. Okay. And then that's up 13 millimeters. And then we have another thing here. And that is 30 millimeters. And that's 51. And that is the drawbar power head. Not bad. And again, this is only like 9,000 more, 900 more RPM. Well, technically, about 860 RPM higher than the original Tormach. The Tormach 1100, at least. Okay, so now what is our weight? And again, this has got a hole in it. What drawbar is it asking? .16 millimeter diameter, long screw bar. Okay, so pretty much what we'll do is we'll just do that. I mean, and then the BT40 taper is going to be a little bit less weight than that, so this will give us a better idea of what that is. Cut through all. Flip and save, open up. Alright, so now what are we at? Properties. .9646 divided by 16. 603. You know what? I'm curious if I could look at the entry package. Man, hopefully we can build this thing for less than it costs for an enclosure on this guy. Does it have a weight, shipment weight? It does not. So if it's 1,600 pounds, I'm gonna say, not including all the electronics and stuff, and the enclosure. It's probably 900 something pounds. Anyways, okay, so now that we got that, so again, oh yeah, so we're at 603 pounds now on ours. So we're getting close. I mean, theirs is still 1,000 pounds more, but we still need to add a motor. We still need to add this gantry. Some sort of box frame, something. And then we still need to add gussets, supports, ATC, a piece that goes on top of this, right? Some sort of bolt down so that we could have changeable jaws. So we go down there, face it with this machine, go now face it, and then bolt down some jaws onto it. Drill some holes, one here, drill some holes here, and then bolt down the jaws. And then we already had the motor, 1, 2, 3 motors. Maybe some bigger motors. We need 1, 2 more lead screws. We need table. We need a big table. So that's probably going to be at least 100 pounds or whatever. So at least 700. So, and then the motor, if it's a big motor, then electronics and possibly brushless at some point, and also the collet, whatever we put in there, tool holder. So there's a couple things. Okay, so now basically what we need to know is, again, on this drawing, from the bottom to the center is 60 millimeters plus or minus 10 thousandths. So 60 millimeters from the bottom up. And basically what we need to do is we need to go from here to there. So this 14, so that's 7. Wait a second. So pretty much what it needs to do is it needs to go out to the middle of this table. It's 28 inches, so it needs a cantilever 14 inches. So this is 60 millimeters. Okay, so we have 2 inches down. Actually, let's see, what is the actuality that we need here? Okay, so that's max. And I don't have my writing utensils right now. So negative 15.75. And we're going in. That's fine. Minus 1.90 equals 17.65 divided by 2 is 8.826 minus 2.3622. So that means we have 18 inches, about almost 18 inches of, total travel. So that means we have 8.825, which is smaller than a Tormach. Oops. Minus minus 2.3622 equals 6.4. But I mean, well, we might have it be, it might be sturdier, I don't know. Anyways, so basically what we need to do is we need to overhang. So let's go on Trello. We need to overhang 6.4628 additional. So here we're going to say design parameters on our Trello as a new list, and we have power head overhangs from center is 60 millimeters with 2.3622 inches. Total travel of system is 17.65. Wait a second. Oh, it's not even 17. I made a mistake. Because it went from negative 15 to negative 1 something. So negative 15.75 minus 1.9 equals negative 1765. Wait, what? $15.75 minus 1.9 equals, there you go, 13.85. 13.85 total travel. And then, so I'll show you guys what I'm doing here. 13.85 total travel, which is 15.75 minus 1.9. Then we need to divide that by half. So, basically the biggest part is it could go this way 7 inches, but this way 7 inches. Well, travel, yeah, but we don't even, so 13, 14 inches. Okay, so let me get this straight here. So 14 inches this way. Okay, so 14 inches this way. So if it's out in the middle of the table, it could go 7 inches this way and 7 inches this way. So theoretically, it should have that travel then. But the question is, can we fit a 14-inch piece on the table? I don't think the table's 14 inches long, wide. Oh, look at those design parameters, man. It's like I knew what I was doing somehow. I don't know. Even though it's been stretched out quite a bit long project now at this point. Okay, so 13 point whatever. And so power head needs to overhang by an additional 4.5. Can I copy this? Oops, wrong button. So that is the space that we have to put our that we have to add to that system. So it needs to overhang by another 4.5 inches. So that's basically how big our motor could be, which is really big, which is about 120 millimeters. So let's see. I think these are 65. Oh, 80 millimeter. Oh yeah, you can put a big guy. And that's including the bracket, so you have plenty of space. So if I did want to use one of these spindles, I could do that. But obviously no rigid tapping, so eventually I would want to do the, what's it called? About one system, what was it called? O-Drive. But I don't know what's the maximum wattage. Oops. Sure. Okay. What's the maximum it could pump out? Oh, sold out. Oops. Oops. Maximum voltage. It's the biggest one they have on there. Ooh. It's 5 horsepower. Maximum current, maximum voltage is 70 times 48 is 4.4 is 3,360 divided by 750 is 4.48. But the question is, how do you pump that much DC power into, you have to buy a really expensive power supply pretty much. Alright, so we are over time here. So we do have on our Trello, we have how much overhang that we need to do, and that gives us the options that we have for our motor setup. Probably not going to start out with O-Drive, probably start out with something else, because again, we're going to need 2 of these guys. We could start out with 1 for the spindle, but then we need to figure out, what kind of power supply can we run to get DC power like that. Or maybe a battery or something. Battery with a high, a very high rate of charge, pretty much. Because I know we have some 750 watt chargers, but you need something like 3,000 watt charger. Anyways, So that would be cool because then you could do rigid tapping and all that cool stuff, and also really good rigid tapping, and then maybe even all the directions. We have very, very fine control, especially with a 4mm pitch screw. That would be amazing. So we'll figure that out later on. And then at that point, we might want to upgrade this because basically the O-Drive controller is going to be at that same cost as a power head. And then buy all the rails, buy a set of rails for each of this. So I guess pretty much each set of components is going to cost almost that much. All right, we'll talk more about it next time. This has been Steven from Legit Tech Tutorials and the Green Engineers. I thank you guys for watching. If you like this video, please subscribe for more videos like it, and I'll see you guys in the next video. Take it easy. Peace.